Not out loud. That's what's called the overall reaction. Sometimes they'll give you that as well. But you would ignore that. Not ignore it, but you don't count it when you're doing the steps we talked about yesterday. What did you get on it, Ben? Unless you don't want to tell people. The ACT.
It was good, but my math school sucked.
That's pretty much how mine was. And then I fixed that, and then I ended up with a 27 overall.
Yeah, see, my math score was 24. It wasn't bad.
But not very many people can say that their ACT was almost the same as their GPA minus a decimal point.
If anybody in here gets a 32 or up, I hate you guys.
There's.
Wait, you got a 32.
Let's burn our house down.
Grace, you're gonna get there. I'm kidding.
I'll bet there's. I'm gonna look at everybody. I'm looking at everyone. I bet there's at least 5 people in here that will get above a 30. That would be my guess.
Cooper already got a 30. Yeah.
I said above a 30. Cooper Lloyd got a 30?
Yeah.
Oh, Derek will get a 36 then.
It's anything like me.
Is someone better than Cooper Lloyd at AP US History? Is that what you're telling me?
At least Derek knows how to spell And then means
No.
I can't spell that.
Spelling is not a sign of intelligence. That's truth.
For Ella Davidson, like, and everybody, the ACT honestly is kind of a game.
It truly is.
It doesn't like.
It measures how well you can master the ACT, not general intelligence.
I would bet Derek, if you think it's that way, he'll do probably pretty well.
Yeah.
He's
So then should we think Derek got it?
Honestly, your ACT is more important than your GPA.
for me it was.
Well, that's because the college didn't know that you could take an easy class and get a 4.0.
Yeah, but weighted GPA. My weighted GPA would be so high.
Were you here yesterday?
Yep.
Okay, good. I didn't mark you absent, and then I'm like, wait, I can't remember. Okay, doesn't matter. This does though. Did anyone else get this as the answer?
Yeah.
Piece of cake. Do we care about this? Nope. It's the slow and any reactant before it. So it's just NO2Cl to the first. I already did that one. Try this one. You should already be done. O3 to the what? NO2 to the what? Are we comfortable with these? They're really pretty easy.
After slow parentheses. And you take all this stuff on the left side. That's going to be the right side. Left side. The right side of fast.
Why don't you take the fast one? Because when we're talking about rates, the fast one, it just happens. The slow is the one that describes how fast something happens. So like if I'm growing up as a kid, if we couldn't leave the table till everyone was done, we just cared about how long it took my sister Emily to eat. It didn't matter if I ate fast. She was the slowest eater on the planet. And we were old school family. Like you didn't leave till everyone was done. And my goodness, I finished 10 minutes ago. No, because we couldn't be. So it was like, no, you can't. We're not done. I'm like, ugh. No, heck no, we don't even eat at a table. We're terrible people. We eat in the kitchen around our little bar. All the kids sit right here. My wife and I just stand right here happily ever after. The whole time. She wears a dress. Just want to annoy them. They love it. Secretly, I know they like it. My daughter's like, oh, that's so cute. And my son Jason's like, nah, that's disgusting. He just rolls his eyes. He's too busy texting people now, actually. It wasn't, I was fine with it.
The third hour, it's a lot worse.
I can understand. that.
Okay.
Does he ground himself more?
Yeah.
Who got that right? That girl, that kid? All right, most people did. All right, so all we're saying is since this is slow, we care about it and anything before it. But why was the NO3 gone? All right, it's a product and it's a reactant. It's both produced and consumed. So really, these are the actual things happening. Then you might notice, by the way, these things show the overall reaction as well.
You look at the slow and the fast.
You look at the slow and anything that happened before it, but never anything after it.
So we can have a list of like fun things.
What does that happen?
You could.
So if you had the slow and the fast, you would move all of them. But if you just had the slow on the top and the fast was after
Which
it,
is what we did before.
before you-
Okay, now these things, if it ever asks you for the overall reaction, then you would care about everything. You would just cross out any intermediates, which it's just like spectator ions. We've done it before. NO3 gone, gone. So we had one O3 plus two NO2s goes to an O2 plus N2O5. All right. It's,
Gases react with each other and make more gases.
yeah. Yeah. All the time. If you took a warm shower today, it was probably when methane, which is a gas, reacted with oxygen to make carbon dioxide and water, both gases, and it provided heat to warm your water. Yeah. All right, last one. You don't need to worry about this part right here. Oh, ouch. Now, on the test, I don't underline the intermediates. You have to identify them. So what order overall would you say this reaction is? Overall, it's second.
Oh, because there's two things.
Okay, bimolecular, that's an answer. It's not the right answer. No, you're right, but it's a different word. Everyone listen, because this is good. He's answering this question. What's the molecularity of this reaction? And it would be bimolecular. I asked what the overall order is, and that's where you add the two. I2 is to the first, okay, because it's slow at the end. Cross out the intermediaries, you're left with this and this, right? There's only one of each, so there's only one exponent for each. So these are raised to the first. So independently, it's first order to iodine, first order to hydrogen. You're fine. And then overall, it's a second order.
You just add the exponents.
Yep.
Is Fabian here today?
Fabian, oh, it's too quiet in here for him to
So we
be
need
here.
both of those going to Fabian,
Tomorrow?
whenever you see him again. Can I have Walker Coleman?
What?
Are you Walker?
Yes.
Let's know. Thank you. Thanks for letting me interrupt.
You are
Have a
welcome.
good day.
You too. All right. What do we think about this? We all right? Okay. We already did this one, did we not? Okay. So we did all the way to here. Now it says E. The following sequence of elementary steps is proposed mechanism for the reaction. These are the three elementary steps. Based on the data presented, which of the above is the rate determining step? I love how we figure this out. So coming up here, just as a reminder, we had this was doubled and this was doubled, right? So we know H2 was to the first. You okay with that so far?
Yeah.
All right. We knew this was doubled. And this was 4. So NO would be to the second. Okay, so what we look for, you take all of these. We need 1 H2 and 2 NOs. And as soon as we meet those requirements, that's where we stop. So right here, remember, we're looking at these parts technically. Here are two NOs, but is H2 there? No. So we would know this is a fast step, but we're close. Down here, N2O2 is an intermediate, and I'm left with H2. I have one H2 now, and I have two NOs, so I would know this is my slow step.
Why would it be so because of that?
Because it's how
Because you already have all you need.
Wait, go back to how you know it.
Okay,
Do another
well,
example.
stop talking and I'll try again. We know that rate can determine the molecularity, or the molecularity can determine the rate law, right? And we said just not too long ago, we could do this. Was that correct? This wasn't too bad. The rate law accounts for everything in the slow step and anything before it. So we can also say that if we have all the steps, but we have the rate law, we can do it in reverse. The rate law has to account for anything that's here and the number of them. And as soon as I meet those requirements, I stop moving down. So let's try it one more time. I knew H2 was to the first and NO was to the second, right? So I know this is the rate law based on these items of data. So one more time, I come down here, and just to clear things up, maybe get rid of intermediates at the start. And that might help you. All right, I think I got them all. All right, so now we're looking for the steps that will get me one H2 and two NOs. Thank you. So I look right here. This gives me two NOs. But does it give me everything? No. So I know this is not the slow, so it must be the fast. So far, all right? Okay. But I have this part taken care of. So now I need a step that gives me one H2. And that would be this step. So since I did not have two H2s, I know this one must be the slow one. And this one I can ignore.
Slow is just practically when it's all completed.
Yep. Now, the chemistry still happens. This whole chapter is about the speed of the chemistry. Like all this stuff is still important, but not for me determining how fast.
What's the importance of speed of a reaction?
Oh, it's tremendously important.
But
Like you got to know how fast your car can accelerate. That's going to have to do everything with how the gas mixture ignites and it burns. Your airbag, that needs to be an exact time of a reaction.
yeah, otherwise you'll
Rates are huge. I'm not done with this problem yet. Okay, now, if this was not here, another piece of this could be F. And it could say, write the balanced overall reaction. Now, the balanced overall reaction, I'm going to get rid of this. I cross out any intermediates. And then I write out everything that's left. I have two NOs. 1, 2. I have two H2. And I go to N2 plus 2H2O.
Hey, who's Williams? It's not the psychology.
Uh-oh.
For 1 second, let's get about this.
Who is the person?
Is it the art teacher, William?
Aislinn.
Oh, the sculpture class on.
Okay, yeah.
You know who Mr.
It's like
Williams-
in Goddard's room, but in the other
Conrad.
hall.
Okay, there wasn't a name tag on her door, and so I didn't go in.
It's a man.
Yes, white.
Hand that to Gabe. Okay. Does everyone understand where I got this from?
Yep.
I took all the reactants that were not intermediates, all the products which were not intermediates, and I just combined them. Okay.
For the, which number, would 2 be the answer? For that last one, or that last
2?
Yeah, would you say policy? Okay, based on the data-
Oh, yes, sorry. Yep. When I wrote slow, then yes, the step 2 would be the rate determining, because that is when the rate loss is completed. It's a great way to put it. Okay.
Is it always the slowest
Yes,
Also,
always.
be the rate determining step.
Yep, exactly. Okay, here we go. Catalyst. This is the last thing. So it's good because we need to move on to the review.
Yes, we are.
A catalyst. Pretty simple. Catalyst increases the rate of reaction by decreasing the activation energy of the reaction. Catalysts change the mechanism by which the process occurs. So a catalyst is like a tunnel. Instead of going over the Rocky Mountains to get to Denver, Colorado, you go through some tunnels. You can get there a lot faster. All right, if you fly, then the catalyst is the plane. That would be exothermic. Okay, so what we have here, we have this process happening, but if we add a catalyst, all right, then it changes the way that it works and it can happen faster. I don't even know if there's more than one slide after this left. I'm sure there is, but I swear we're there. I just like to hit myself in the head, can't we? Well, that's what's coming up. All right, good idea. That's a great idea. All right, catalyst. One way a catalyst can speed up a reaction is by holding the reactants together and helping the bonds break. So we brought this up last night. Who's ever seen Hitch? The movie Hitch.
What's Hitch?
I love that movie.
All right, let me talk. Yeah, that's the same movie. In Hitch, Hitch is a guy that people hire to when they're kind of weird and they want to have a relationship with someone, but they're too weird. They can't figure it out. So
I feel like people would do that.
so Hitch is the catalyst. He brings the two people into proximity in the right conditions, causes the romantic moment to occur so that they can both fall in love.
So he's a wingman.
He's a wingman. All right. It's actually a really funny movie if you get a chance. I think it's mostly appropriate. All right. And you can learn how to kiss someone. Yes. It's called the 90-10 rule.
Cooper makes me sad. I'm scared.
He makes me sad too. All right, this is the end. Enzymes are natural catalysts in biological systems. Oh, hello. How are you guys doing? Good, good. All right. So in a biological system, we have these natural catalysts. They are called enzymes. If you remember from biology, an enzyme is something that grabs a chemical called a substrate. All right, the substrate, Goddard cannot keep his business out of other people's business. Okay, moving on. The substrate is the chemical. The enzyme brings it together, helps it to break, and then you get the products that come out. Easy enough?
How does it make it break?
It doesn't make it break, it just helps that reaction that was going to break or form. It can both, it can go either direction. And then the enzyme stays, these move out and life's grand. Yep. I'm probably going to get yelled at again. No, it's the fire marshal. It's my yearly inspection. I'm looking back there right now. I think we're mostly compliant.
Well, one of the fire extinguishers says, I remember
I'll-
that, and it's a safety hazard.
Yeah, I'll bet ours are too. Okay, here we go. What does that say in the top left corner? Test review. The more you talk, the less we review. This is pretty much on your exam, so I would draw it, make sure you're there. I don't know how much I got.
Cooper, you make me uncomfortable. I just get uncomfortable.
Okay, here we go. What's this line at? 20. What's this line at?
35.
And what's this line at?
14.
14. That's all you need. Right here. Yep. Exo ends lower.
But
This is
endo would
energy
be
loss.
ending higher, right?
Endo. Sorry, this was confusing. These are two separate problems.
So the activation energy is always higher than the exothermic or endo.
Yes. It can be really, really close, but usually yes. Okay, the other one, it's pretty much the same thing. You have to label stuff, but I'll move it on. All right, here you go. The initial concentration of a reactant in a first order reaction is 0.27. The rate constant for the reaction is 0.75. What is the concentration mole per liter of reactant after 1.5 seconds? So it's first order. I need the first order integrated rate law, which is,
Wait,
I don't remember it. Whoops, that's an H. It's supposed to be an LN.
the constant.
Oh, isn't that what we were debating, if it was negative or not?
Yeah, the other one's the other one.
Is it always a negative case?
Is this correct?
I think it's AT and then AML.
Oh, okay.
Yeah, it's 18 and then. Wait, does it not go outside in the parentheses?
That's the equation you use for this, yes.
What if we put, so it's a negative K applied to the second order?
That's where we had our debate. And I forgot to look up because I was too busy partying with you guys yesterday.
Oh, yeah, that was fun though.
It was medium. It was fun. So what of these, all these things, what is this asking you to solve for?
It's asking you to solve for the concentration.
So which one?
So
It's asking you to solve for AT. He can't not.
So the negative is never important.
It's definitely important.
Well, but you just make it a positive.
Yeah.
You always make it a positive.
No, this is not on this.
What?
K is a value that is always positive. In this problem, K is a positive number
Yeah.
with a negative sign in front of it.
Are we sure?
This one 100% positive,
I don't care.
So you take, because K is equal to 0.75, right?
right?
So you take negative 0.75 times 1.5.
Yep.
And then you add it to the ln of 0.27.
Yep.
Does it matter if it's in moles or if it's in other things?
Not really.
But it should always be in moles, right?
That just gives me-
Mole per liter or molarity. It could be pressure. It doesn't matter.
Negative 1.39.
Did you just do second ln times 0.27? Or I mean the natural log of 0.27.
Yeah, you don't, you take the natural log here. When you go to solve this, you take the second log or e raised to this answer. Okay, does anyone have this right side, just the right side, not the overall answer? All right, then, how do I solve for the ln of something? What's the inverse of it? E raised to the negative 2.43.
Wait, why do you do that? Oh,
Because that's the inverse of this. So what do you end up with?
0.08.
And what would that unit be? Molarity or mole per liter. This problem wrote it as moles per liter, but that's molarity. So either one is fine.
Is liter capitalized?
That doesn't really matter. Okay, we all right with that idea? Okay, good. Here we go.
I'm from other.
What happened?
Well, I just got 2.43. That's all I know.
It was negative 2.43. And then
How did you get 0.08?
I took in my calculator E and I raised it to this value. The inverse of the natural log is E. So like usually you'd say, oh, divide both sides by the ln, but that's not how ln's work. And whenever you said, all right, well, I'm going to divide, that's you were taking the inverse of multiplying. The inverse of ln is E raised to whatever this number is. And that gives you your answer. Possibly ask Misha, she's smart. I sense that. An intermediate. All right, we good? This one's fast.
Yeah, that's fine.
So the intermediates, I'll go B first. What is the only intermediate? HI. So that means I can cross these out, then I write the rest. H2 plus 2ICl goes to I2 plus 2HCl. Okay, coming back here, if the first step is slow and the second one is fast, so right there, I'm just going to get rid of this myself. It's just this. It's the slow and anything before it. There was nothing before it. So the rate law would be rate equals K times H2 times to the first, I guess, ICL to the first as well. Piece of cake on that one, hopefully. All right. Yes, Cooper.
Actually, maybe flip the next slide and I'll ask it. Okay, so are we gonna have to do one where you have to like use the calculator?
Yeah, absolutely. All right. So it gives you this data. It wants the magnitude of K.
Yeah, I have a lot of pictures of the back of the front row set. And gay.
He's got good hair. Gabe was my favorite during the soft closure because he's the only one that had himself in his pictures. I liked him. He'd have his homework up like this. I was like, oh, I miss my game. How'd the note passing outing go? Sorry. Oh, oops. The world explodes.
What happens when B doubles and A is a constant? Is it just a zero? Yeah. There's no change.
B would be zero.
Are we ready? Okay, didn't even mean to ask. I apologize. What time we out? Okay. Good stretch. All right, I'm going to give you 1 minute.
Wow. I did something wrong too.
If you get a number that's on that screen, you most likely think you got it. All right, here we go. Kids don't like this one, but it's actually easier in the long run than most of them. What do we know about B? I heard you talk about it. All right, this changed and this did nothing. So B is not even part of the rate law. Like you could write B raised to the zero, but why waste your time? So rate is equal to, K, sorry, times A raised to some number. So this one's a little tricky because they're not right on top of each other. But you got to go from here to here, and it is what? 3x. From this change to that change, we tripled the concentration. What happened from here to here? It's a 9. How does a 3 become a 9? If it's squared. If it's squared, it's tricky because you're like, oh, a 3. 3 times 3 is 9. No, we're squaring it.
You can also take it, even if they're not right on top of each other, look at the constant.
Yeah, you can take it anywhere you want. Okay, so now just pick a row. I'll write it better. Rate equals K A squared. So I'll just pick the top row. 2.83 equals X times 2.73 squared. Okay with that? So I'm going to take whatever this, does someone have this answer for me? The 0.273 squared? 0.0 what? Okay, so X is equal to this number divided by that, which is, I don't know, what? D? All right, it is that. That's an axe. It's going after your 4.0s. Oh. All right, just kidding. Next. What? All right, so yeah, it's good for you to get your 4.0 broken early. Then you can learn because you want to, not because you need to get a number.
That's me.
All right, so here we go. ln of AT, is that what we said this time? It's first order again, equals negative K. Hold on, let me see what we got next. Because we already did one like that, right? Okay. It's okay. So
We need to practice.
this one real quick, really simple multiple choice. We've already seen it, but if it's ln versus time, the slope of the line is equal to what? Right? Negative K. Good job.
Because it's a negative 12.
Yep. Okay. Kids overthink this one. What is the rate of disappearance of Cl2 when the initial concentration of reactants are 0.5 and Cl is equal to 0.1? All right, it's just a thinker. I just made it up. So you don't have all the answers to the test. It's not a number. Just like every test. Well, it's not something you put in your calculator.
Right. The reactants are.
So if you see this problem and you have a table and you figured stuff out, you can just plug it in. If you don't, the rate of disappearance of Cl2, you would just say 2 times the rate of disappearance of A. That's all. If it doesn't give you more information, that's all you can say. Because there's a 2. So sometimes you can underthink things, sometimes you can overthink them. If you don't have something you don't need, well, then make up an answer that is true.
So it doesn't matter what the moles of that other one was, right?
Nothing really matters.
2 times the disappearance rate of NO. That's pretty cool.
Okay, here we go. Quick on this one. Which one's false? E is the right answer.
Because it's third.
It's third. 1 plus 2 is 3. No. This is the same, but different questions.
About like 0 order, like how would like that work?
So an easy example of that is when you add solid magnesium to concentrated hydrochloric acid. The concentration of Mg doesn't really matter. It's only relative to the concentration of H plus because a solid doesn't really have a concentration.
Because it's not.
Can you only delete one intermediary for one intermediary?
No. Well, they have to match, but you can have more than one type of intermediate. This one has 2.
So let's say though that CO1 on the second line is slow one,
Yeah.
first product and then 2O. Say that would be CO2 as well.
Then we'd have 1 and 2O on the right side. They have to match.
Yeah, but like you could delete all those and 2O2s.
No, you could delete 2 of the 3 of them.
Oh, so just one on one side, one on the other side.
Yep. Hold on. Go ahead, Judah. Wow. Yeah, they're on the right side and the left side. If they're on both sides, then they're not really part of the reaction. In this step, it made it. In this step, it consumed it. So it wasn't, it's really not in the reaction. Same with N2O2. Yep, because the balanced equation doesn't care about fast or slow. The rate does. Okay, the intermediates are the things that I circled and then crossed out. We'll be fine there. Explain your reasoning. It's because you would say it was produced in one step and consumed in another. Part C. Yep.
Explanation of part D.
Of B, you would say N2O2 is an intermediate because it was produced in one step and used up in another. That is correct. Okay, so number one is true. It is third order because 2 plus 1. This is false. The mechanism involves the simultaneous collision of two NO and an H2. That is false. It takes two NOs to collide to produce this, and then a next step that collides with H2. So we don't have NO, NO, and H2 running into each other. If we did, it would say NO plus H2, and then an arrow. Since H2 is in a different step, it is not simultaneous. All right.
Oh, so that's why it's wrong because it's simultaneous, not the.
Well, it doesn't, yeah, they don't collide. They don't all three collide at the same time.
Yeah, two of them collide and then the two collide with another.
Yeah. All right, explain why an increase in temperature increases the rate of K given the rate law in C. K is temperature dependent because the higher the temperature, the more collisions. The more collisions and the more energy, the faster the rate. Like that's not a great answer, but I had 15 seconds. We did not do any of these. If you want, take a picture of this and practice it tonight and ask me in the morning. Yeah. You'll get all the equations. It is an equation.
How do we do half-life? Is it just?
Use the equation or you look at a graph. If I feel like it. I'll pray about it.